Welcome back to the final video series exploring measures of variation. Specifically, we're going to take a spotlight look at standard deviation. What does this calculation actually mean? How can a standard be a deviation? Maybe you're like this dinosaur asking yourself the same thing. All right, so we are going to practice looking at scores on a test. We're going to look at percentages, scores on a test. Specifically, we're going to take a look at what happens when we have an outlier. So an outlier, as this lovely image over here suggests, happens when we have one score in our data set that is not like the other scores. So in this example, there was some tests that 8 people were given. Fairly easy test. Most people did pretty well, except person number 7 did not do so well. So person number 7 is an outlier in this situation. They are not quite in line with the rest of the data that we're looking at. So we're going to use this as an example of how to understand what does standard deviation actually tell us. So we are going to do some calculations first. Move myself out of the way. So if we want to find standard deviation, of course, the first thing we have to do is find the average. We're also going to do this plotting the data, plotting our responses, as is indicated by this lovely dotted image on the screen. So we're going to visualize what is it that we're looking at here, what is this information telling us as we walk out the steps of calculating standard deviation. So again, first of all, we have to find the average. If you would like to practice calculating the average yourself, I would encourage and invite you to hit pause on the video right now. Take a couple minutes to do so. If you feel confident, let's move ahead. So here are all of my X scores, all of the scores in my data set, including the outlier this time, with the outlier this time. I have 8 people represented in this data set. When I add all those scores up, I get hopefully the same thing you were getting, 692 out of 8 divided by 8, which gives me about 86.5. So if I'm going to visualize that, here are all of the scores on my data set. So here is person number 1, number 2, number 3, number 4, 5, 6, 7, and 8. We don't have a 9th person, so ignore that part. But here are the 8 scores on my data set. The average for this group is about 87%. I'm going to go ahead and round up from 86% even for simplicity's sake. So the average is about 87%, which puts that line right about here. So we're going to come back to this image. We're going to use this to visualize what is standard deviation actually telling us. But first, we have to then actually calculate the standard deviation. Here is our equation. Let me move myself again. So here's our equation. Again, I would invite you to take a pause, hit a pause on the video, see if you can map this out by hand, get your practice at calculating this lovely statistic. And when you are ready, let's go ahead and move forward. So here are all of those numbers mapped out into our equation. So I've got person number 1 score of 100, minus the average of 87 squared, person number 2 score of 85, minus the average squared, etc., 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 etc. I would again encourage you to take the step of then condensing this information, see if you can get all the way to the standard deviation calculation. Hit pause if you haven't done that yet already. Here's what I ended up with in simplifying these numbers. So this is some bigger numbers. I definitely want to use a calculator to square 13 and 7 and 9 and 33 and etc. Once you use a calculator to map out all of that, hopefully this is what you've gotten. And when you add all those numbers together on the top of your equation, hopefully you get what I've got here, which is 1,442. If we take 1,442 divided by 7, we get 206. And when I take the square root of 206, I get 14.35270009, etc., etc., etc. That one's a little bit easier to round. 14.35 is our cutoff point. So 2 decimal points is where we're keeping it at. So I get a standard deviation of 14.35. All right, we'll come back here. Remember this number. Now let's do it again. Same set of steps. This time we're going to exclude the outlier though. So the first step, I've mapped out all these scores again. This time person number 7 is not represented, but here's all these other scores that we've already looked at. So we're going to fill in the equation again. I'd again invite you to pause the video at this point to check your calculations against mine. Give yourself a little bit of practice. Hopefully this is what you end up with. Note that this time our n is 7 because we've excluded that person number 7. So now we only have 7 people, not 8, represented in our data set. When I add all those numbers up, I get 638. When I divide that by 7, I get 91.14. So for simplicity's sake, again, because we're going to be calculating standard deviation and decimal points make that incredibly more complicated, we're just going to round to 91%. The average score of this group of 7 students is 91%. So here's how we would visualize that. If this was the 91% line, we've got scores underneath it, we've got scores above it. Next step was standard deviation. Again, hit pause so you can practice. When you are ready, let's proceed. Check your answers with mine. Here's all my numbers plugged in. Again, this time the n is only 7, so 7 minus 1 equals 6. I'm going to condense all that information down in parentheses, subtract all those values from one another, end up with a simplified version. Mapping out all my steps to make sure that I don't forget anything along the way. When I square all those amounts, here's how that calculates out. And then when I finally add all those amounts, I get 233 over 6. 233 divided by 6 is 38.83. 38.83. Taking the square root of that gives us about 6.23. So hopefully that is what you got for standard deviation as well. All right, why does this matter? So here are our comparisons. These are the numbers that we've just calculated. These are the images that we've already seen. We've got one side over here with the outlier. We've got the other side over here without the outlier. We can see that the average has shifted slightly, but my goodness, that standard deviation is quite different, isn't it? So again, this is an illustration of how the average is a helpful number. It tells us something, and it doesn't tell us enough about our data set. So in this first example, with the outlier, the average score was 87%. Without the outlier, it's 91%. Those are pretty close. If I was not paying attention to standard deviation, if I was not paying attention to measures of variation, I might think that those two groups were like basically similar. However, the standard deviation calculation tells me a very different story. It tells me that there's something else going on here. There's something else happening in these numbers because the standard deviation of with the outlier is over double than the one without the outlier. So let's visualize that. Let's take a look at what that means. So essentially, what standard deviation is doing, standard deviation is calculating on average, how distant is each score in your data set? How distant is that from the mean itself? So it's taking a look at these spaces here. So we can see these red arrows. It's taking a look at how big is this gap? How big is this gap? How about this one, this one, this one, this one? This one's huge, and that one. So what standard deviation is doing is it's calculating the distance between each of your individual scores and the average and the mean, and then it's averaging all of those distances together. So when we see a standard deviation of 14.35, it's telling us that on average, all of our scores were about 14.34 points, percentage points in this case, away from the mean. So it's telling us that on average, all of our scores are about within 14.34%, 14.34 points, whatever your number is, of the mean. So it's giving us a range of how variable, how much those numbers are varying. On the other side, if we were to do the same thing, this is looking at the data set without the outlier. We've crossed out that 54%. We're excluding them from these calculations. We're pretending we just have 7 people instead of 8 this time. When I look at when our standard deviation calculation calculates the average distance between each score and the mean, and then it takes the average of those distances between each score and the mean, this time it's a lot smaller, right? We can see that reflected in our data set as well. So this time the standard deviation is telling us that on average, all of our scores are about 6.23% around the mean. They fall above and below about 6.23% of the mean. So on average, things are much more congregated close together when we exclude the outlier. So of course this makes sense. This is what standard deviation is essentially telling us. It's telling us on average, how much do scores deviate from the mean? It's giving us more information about our data set. It's telling the other side of the story of central tendency, of the average in particular, because it's giving us a better understanding of how our data is dispersed. So taken together, taken holistically, all of these measures, all of these calculations are helpful ways of being able to share information about our data set so that we might be able to communicate statistical findings, so that we can make meaning of math, so we can do all the things that statistics is here to help us do. So I hope this has been helpful and interesting, maybe interesting, hopefully a little interesting in terms of understanding what are these numbers actually doing. So now when you open a journal article, when you see some statistics in some report or the news or whatever, when someone tells you here's what the average is, here's what the standard deviation is, now you have a little bit more of that understanding of what are you actually looking at. Because that's all statistics really wants for us to do, is to figure out how do we make meaning in a way that makes sense about the world around us. All right, I will catch you next time. Happy calculating in the meantime.